Tonight, you're listening to Nighttime Knowledge, a quiet place for calm explanations of current scientific and geopolitical topics. This is not a news update. There's no urgency here. You don't need to watch. There's nothing on the screen you'll miss. Just listen. When people talk about Greenland's minerals, the conversation often starts with a simple image: hidden wealth, a vast island, untouched ground. The idea that something valuable must be waiting just beneath the surface. This image is powerful. It feels intuitive. If resources exist, why would they not be used? But this way of thinking compresses time. It turns centuries of geology and decades of decision-making into a single, impatient question. Why hasn't it happened yet? To answer that calmly, we need to slow the story down. Because minerals do not exist in isolation. They exist within systems: geological systems, economic systems, social systems, and natural systems that change only gradually. Greenland is often described as resource-rich, and in a narrow geological sense, that description is accurate. The island contains deposits of rare earth elements, uranium, iron, zinc, and other materials that modern technologies depend on. But presence alone is not enough. Minerals only become resources when several conditions align. They must be reachable. They must be extractable. They must be transportable. They must be processable. And finally, they must be saleable at a cost that makes sense not just today, but over many years. This is where the story becomes slower and more complicated. Greenland's geology was shaped over immense spans of time. Not years, not centuries, but hundreds of millions of years. The island sits on some of the oldest rock formations on Earth. Continents shifted. Mountains rose and eroded. Layers of rock were compressed, folded, and transformed. Minerals formed slowly, under pressure and heat, long before humans existed. Later, ice reshaped the surface. Glaciers advanced and retreated. Material was scraped away. Some deposits became exposed, others remained buried deep below. Understanding what lies beneath Greenland is not a matter of looking at the surface. It requires surveys, measurements, careful interpretation of indirect signals. Even then, certainty is rare. Geology offers probabilities, not guarantees, and probability alone is not enough to justify extraction. Geography adds another layer of constraint. Greenland is vast, but its infrastructure is limited. Settlements are small and widely spaced. There are few roads connecting them. Ports are essential, but they are often far from mineral deposits. Much of the interior is inaccessible for most of the year. Weather shapes everything: storms, ice, long periods of darkness. Mining operations depend on predictability. In Greenland, predictability is seasonal. This affects cost. Heavy machinery must be transported. Fuel must be shipped. Workers must be housed. Every logistical step adds expense. This brings us to economics. A mineral can be valuable and still not be profitable. Extraction costs are high. Market prices fluctuate. Global demand changes. Investments are made over decades, not months. Companies look for stable conditions. They ask not only, is the mineral there, but will it still make sense in 20 years? Social factors are equally important. Greenland's population is small. Communities depend on their environment in direct ways: hunting, fishing, local travel. Mining alters landscapes permanently. Decisions, therefore, involve trade-offs that go beyond economics. Employment opportunities matter. So does cultural continuity. Since self-government, Greenland has the authority to decide how resources are managed. This means projects are discussed locally, permits are evaluated carefully, public opinion plays a role. Environmental considerations are never far from these discussions. Arctic ecosystems recover slowly. Disturbance can last generations. Waste management is complex. Once land is altered, restoration is uncertain. In such conditions, deliberation is not delay. It is responsibility. At the same time, interest in Greenland's minerals persists because modern technology relies on specific materials in subtle but essential ways. Rare earth elements are used in magnets. These magnets are small, often invisible, but they perform critical roles. They allow electric motors to be compact and efficient. They make it possible for wind turbines to generate power reliably across changing conditions. They appear in medical scanners, where precision and stability matter more than raw force. Without these materials, many modern systems would still function, but they would be larger, less efficient, more fragile. The same pattern appears in batteries. Energy storage depends on specific combinations of materials. Each element contributes particular properties: energy density, longevity, thermal stability. Small changes in composition can affect performance significantly. This is why mineral supply chains are not easily substituted. It is not just about quantity, it is about consistency. Electronics offer another example. Modern devices rely on carefully controlled electrical behavior. Semiconductors, conductors, insulators, each requires materials with predictable properties. Even tiny impurities can affect performance. This makes sourcing important, but not urgent in the everyday sense. Manufacturers plan years ahead. They diversify suppliers. They store reserves. They design systems to tolerate gradual change. For most users, this complexity remains invisible. A phone works, a computer starts. Navigation responds instantly. Behind these simple experiences is a layered system that absorbs uncertainty. Minerals are one part of that system, not the most visible part, but an essential one. This helps explain why interest in Greenland's minerals can coexist with patience. The technologies that depend on them do not require sudden extraction. They require reliability, predictability, and time, which allows decisions to remain deliberate rather than reactive. Yet scale matters. A single device uses very little material. Demand accumulates only across millions of units. This explains the tension. The resources matter, but urgency is limited. Future developments may change the equation. New extraction techniques, better infrastructure, shifts in global demand. Climate change may even alter physical access, but these changes unfold slowly. They do not erase constraints overnight, which leads to a final perspective. Resources underground represent potential, not obligation. Leaving minerals untouched can be a strategic choice. It allows time for technology to improve, for knowledge to deepen, for societies to decide on their own terms. In Greenland, restraint is not inaction. It is a reflection of scale, of distance, and of the understanding that some decisions are best made slowly, deliberately, and with an awareness that once extracted, some things cannot be put back. If you're still awake, thank you for listening. And if you've drifted off, that's exactly what this was meant for. New episodes are added quietly, without notifications or noise. Wherever you are, and whatever time it is, I hope this helped the world feel a little calmer. Good night.